Welcome, everybody. Thank you for joining us today for this Factor This webcast, IoT Alert to Action, How Renewable Energy Operators Are Closing the Maintenance Gap, presented by Verosoft. We're going to spend the next 60 minutes on something specific to renewable energy operators. That's the gap between detecting an issue on your assets and actually doing something about it. And that gap costs availability, it costs megawatt hours, and it shapes your position with the off-taker, the lender, and the OEM. Over the next hour, we'll show you how a handful of renewable operators are closing that gap. Before we get started, a few brief housekeeping notes. This presentation is both live and interactive. That means you can ask a question at any time. Just type it into the question box. You should use that for any technical difficulties you might be experiencing as well. We do recommend you shut down any other applications you might have open at this time so you can fully concentrate on the discussion you're about to hear and to improve your machine's performance. For your convenience, this presentation will be available on demand right after this live event. We'll send out a reminder email message to everyone who registered with a link to the archive once it's ready to go. You can also find it in the webcast section at factorthis.com. All right, time for some introductions. If you don't know me by now, I'm Paul Gerke, Content Director of Factor This. I'll be moderating today's session and keeping us on time. Joining me is someone who spends his working hours on the exact problem I outlined a moment ago, thankfully, because I don't know too much about it. Hopefully going to learn a bit, though. Ben, please introduce yourself.
Thanks, Paul. So I'm Benjamin Brusso. I've been working at Verosoft for 8 years now. I'm on the pre-sale side, meaning I'm focusing my time on digital transformation for asset-intensive industries. So think renewables, manufacturing, resource extraction. And lately, a lot of my conversation has been with asset operator who already have IoT in place, but they're trying to figure out what to do with it. So today's session sits right in that conversation. I'm happy to be here, Paul.
All right, Ben, just a reminder to everyone here, drop your questions in the chat as we go. Ben will pick them up at the end. Let's get into it. We'll spend the next hour doing the following. We'll start with some context on Verosoft and the operators running Tag Mobi today, including a quick case study from Amin Renewables on the solar side. Then we'll get into the IoT reality and renewable energy and where the operational gap actually resides. Ben will walk us through the closed loop architecture and run a live demo of Tag Mobi. After that demo, we'll come back to a deeper operator story, Voltwise on the BESS side, and the operational outcomes that come with this kind of development. Then practical material, how to start small, who to bring into the room internally, and when that all-important ROI starts to show up. We're holding about 10 minutes at the end for Q&A. If you only stick around for one part, stay for the demo and the Voltwise story. That's where this gets real. Quick credibility frame before we hand it over to the substance. Verosoft, they've been building asset management software for more than 25 years. The product is deployed in more than 150 countries through a network of 40 plus partners. They work across manufacturing, renewables, and facilities. And the reason we're talking to them today specifically about renewable operations is the depth of their footprint in that exact problem space. Martin Turgeon, their CEO, frames the mission as helping companies manage assets effectively, reduce operational costs, and scale their business. That's the lens behind everything we're about to show you. Ben, time to turn it over to you.
Thanks, Paul. Well, first, let's start with a quick context on who's running Tag today. Okay. Don't trust us, trust our customers. So first, we have four broad segments. Okay. So from left to right, manufacturing, energy, facilities, and then resource extraction. Okay. We'll talk a bit more about energy today. Okay. So we really work with utility scale solar operators. Okay. Major oil and gas, think upstream and downstream as well. And now more and more, we're seeing an increasing number of battery energy storage system operators across multiple geographies. Okay? The point I want to make here, Paul, on this slide is that TAG isn't just theory for renewable energy. It's running in production across hundreds, millions of assets, thousands of users across different asset-intensive industries. Okay? The next two slides will get specific about that footprint on the renewable side. So meet some of our major clients in solar energy. Okay? The first one, the biggest one, okay, is in Abu Dhabi in UAE. And at the time of commissioning, which was about 4 years ago, it was the largest single site solar plant in the world at 3.2 million panels. Okay? We have about 1.2 gigawatt of production capacity here. And to put it into perspective, it's powering, think of a mid-sized city, about 100,000 people. Okay. So TAG manages their asset hierarchy, their maintenance workflow, procurement, everything that this site needs to run. Okay. Just another example, we have Siraj 1 in Qatar. Okay. We have the details on the slide here, but what I like, 10% of Qatar's peak demand on one single site that's running TAG. Very impressive. Okay. And then we'll use the last one here. We'll take a deeper dive into it. I think this one's more acceptable or more alike some of the asset operators we would have on this call. Okay. We have a site area of about 4 square kilometers and a production capacity of 125 megawatts per hour. So what happened after Amin Renewable started using tag? Okay, I think if there's one thing you need to remember from this slide, it's the quote down there from BV Kumar, essentially the manager at the site. There is after deploying tag, they were able to see their downtime reduced by 38%. Okay, you see some of the key points on this site. Okay, almost 500,000 assets. They replaced their legacy system, implemented tag, started doing real monitoring. Okay, and ultimately, I like this next slide here with the infographic. It kind of shows everything in one picture that they were able to achieve. Okay, so this shift that they did, going from a legacy system to a very modern architecture, that's the same operational shift that we're going to be talking about the next 45 minutes. Okay, apply to battery energy storage system, wind, or just a portfolio of different renewable. Now let's introduce Voltwise. Okay, so they gave us permission to share this, so I'll get quite specific. Okay, Voltwise is a BESS. Okay, so battery energy storage system. Okay, essentially the whole business model is that they're not generating additional energy, but when it's low demand, they store it, and then when it's high demand, they distribute it across the grid. Okay. Um, what's particular with those types of assets is it's often smaller scale deployment. So they run very lean, but they have a wide range of different assets. So you can see it here in our first block. Think ring main unit, think SCADA system, comm equipment, fire equipment, video surveillance. So a wide range of different asset that needs to be maintained. Okay? And what's great with Voltwise is I think they really they really started with a narrow scope. They knew exactly what they needed, okay? And some of the KPIs they were able to monitor was inverter ability above 95% and battery availability above 95%. Okay? This means that if ever there's an issue with one of those two assets, okay, we would start an automated workflow, a closed loop. Okay, so a practical example: a battery goes down, availability goes below 95%. Tag would create a work order. That work order would be automatically dispatched to maybe it's a technician, maybe it's an outside service provider, depending on availability or geography. And then asset managers, get an instant notification in Microsoft Teams for collaboration. So they started with one site as a pilot. Now they are fully deployed at their 11 sites, and they're expected to double the amount of their sites in the next couple of years. I've been starting to throw some acronyms left and right. I thought now would be a good time for a quick glossary before we go any further. Okay. So on the left column, if you're already an asset operator, this should not be any news for you. Okay, I won't go through all of them one by one, but I think what's important is what we'll talk about today. Okay, so anomaly detection. So really spotting deviation from normal behavior, and often this will be a trigger. Okay, so that would be essentially a rule-based action when a KPI is breached. Very good example is exactly what Voltwise has been doing. A good example, below 95% availability, that's a threshold trigger. Okay? And then closed loop, I briefly introduced it, but let's give it a formal definition. Okay? It's really going from a signal to a work order a maintenance document, execution, someone completing this work order, making a repair in plain English, okay, and ultimately down to cost. Okay, so going from a single to a financial value. All right, if there's one slide on the whole deck here, this is the one. Okay, and I think that's probably why a lot of people are here on this webinar today. Okay, is that most IoT investment, sorry, stop at monitoring. Okay, so if you look at the three steps that we have here, you would likely already have some sensors, you would have a dashboard, okay, and then they would generate alerts. Okay, battery availability is going low, temperature in the fridge is getting high, okay, vibration is out of bounds, but then you need a manual action. You're relying on someone to create a work order or to take a decision. Okay. And to me, that last step is really the break point. Okay. It depends on who's on shift, who saw the alert, what other alerts did they get in that hour, okay, and whether they trust the alert enough to call somebody. Okay. In renewables, here this would actually play out. Okay. An inverter throws a fault and it's always on a Friday evening, right? The on-call technician sees it. They had 200 other alerts that day, and then they deprioritize it. Probably just false alarm. Monday morning, you've lost about 60 hours of degraded production. Okay, and this gets worse if it's on a combiner box. You have to multiply that for the whole array. Okay, so I think here we really understand that the manual action is what blocks the IoT investment. Okay. Been talking a lot about alerts, 200 alerts. Okay. Pay attention to the box at the bottom. Okay. I have a definition of what everyone calls alert fatigue. Okay. It's when teams receive so many alerts that critical warning starts getting ignored or delayed. Okay. There's an old tale. I think it's the boy that cried to the wolf too many times. Okay. Same thing. Maybe type in the chat if that's something you've experienced, alert fatigue, or maybe you already have a solution, some process you've put in place. So we'd love to hear what you've experienced about alert fatigue. I'll tell you how do you actually fix it. Now let's take a quick look at the diagram here. I know there's about a dozen circles on the screen, but I'll break this down for you. Okay. If we take a look at the left, our diagram with the red circles, okay, that's really what monitoring without action is. Okay. So at the center of it all, you have your IoT sensors and signal. That's probably where you're at today. Okay. And then there's kind of a black box all the way until financial analysis. Okay. What a closed loop is with tag is that you have the bridge in between. Okay. You have your IoT sensor signal, and then you have some monitoring rules. Okay. They could be threshold, they could be anomalies like we've discussed. Okay. Or it could be predictive maintenance, even better, fixing things before they break. Okay. Before the signal comes out. And then you have maintenance, so people actually fixing, maintaining the assets. And then all of this is embedded inside the financial systems. Okay. That means that when you have all five layers connected, okay, that same signal is essentially tracking cost in real time. Think the parts that you've used to replace a defaulty asset. Think the labor that's been captured, the time that we've spent, or maybe you needed to have a specialized vendor come into site so we can capture all of those costs. Essentially, even forecasting based on the signals that we get, what should be our budget for maintenance. I think now we've talked a lot about, the why. Okay. Let's talk a little bit more now about the solution. Let's understand the solution. Okay. What Tag wants to do, okay, is really turning those IoT signal into automated action. Okay. It's connecting those assets to real maintenance execution. Okay. Someone boots on the ground going to fix those assets, all while reducing noise and turn sensor data into work orders. And I want to be clear here. The goal isn't more alerts, okay? The goal is early detection. It's less noise, Okay? The next slide will show how a closed loop is wired. And I think a lot of you will relate to this one. Okay. If you are a renewable operator, likely you have a SCADA in place or some telemetry. Okay. So you probably already have that first step pretty much figured out. Okay. First step being ingesting the data. Okay. Feeding the beast. Okay. And then once we have that, we need to go to step two, which is deciding. And this is usually where I see some frictions or some implementation stalls. Okay. Um, a lot of renewable operators run quite lean. Okay. And if you have a reliability engineer, they cannot afford to be coding all day some rules, right? Above or below 95%, then this, then that. And what I think is really innovative with our solution is that you can, in plain English, describe what you want to happen, and then the system will code it for you. Let me give you an example. When an inverter availability drops below 90% for more than 30 minutes, create a work order based on template 1. Okay? And then our AI will transform that plain language into one or many monitoring solutions. Step 3, this one is work. Can't really get away from that. Okay. So once we have that work order, okay, we can have some AI capabilities to dispatch, like I said before, but ultimately someone will need to go investigate or repair the asset. Okay. So if we take a look at those first three steps, this is what I would call signal to action. Okay, which is great. I would say that most organizations are not fully there yet, but we can really take it to the next step, the final step, which is proving. Okay, which is where you want to understand your cost. The work order that we just did, how much time did we spend on it? Did it happen before? Okay. How much financial resources we spent on it, whether it's spares or vendors. And to me, this is really signal to wallet. All right, I'll run into a few slides before we get into the live demo. I know I've been talking for what about 15 minutes now, okay? But it's always good to get a bit of context before, okay? So first, okay, that's probably a situation you've lived through. Okay, you spent 6 months on the last system integration project, probably longer. Okay, and by the end of it, the team was burned out, the budget was over. Okay, I'm kind of describing probably any digital transformation project now. Okay, and now you're being asked to integrate IoT data, and nobody wants to do it again. Okay. A big misconception is that the reason most IoT projects stall is the sensors. That's not true. It's really mapping those sensors to assets, something that's meaningful into your asset management system. Okay. And this is where with Mentor AI, okay, we can really cut this down. So if you'll probably need to lean in a little bit on your screen here, but what you see from the screenshot on the iPad, okay, is we have four different sites. Okay, and you see those sites they're fictitious, okay, but Sunridge Solar, okay, Cedar Valley Solar, Horizon Plain Solar, okay, and on the right we would have essentially what the IoT or SCADA system feeds. And our AI is smart enough to understand those patterns and those acronyms and map the asset. So as an asset manager, all you have to do is review the suggestions. Okay. If the AI was off the mark, you can once again, in natural language, explain some of your patterns. It will resuggest some mapping. And then all you have to do is validate rather than coding this manually and having to loop an IT department, an integrator, developers. Okay. Most of our clients have been successful with Mentor to map about 95% of their assets. To me, that's really the difference between a pilot that ships in a few weeks to a pilot that never really ships at all. We have a few more functionality I want to introduce before getting into the demo. Okay, the one I like here is controlling alerts. Okay, so we've talked about alert fatigue. We have a solution for that. Okay, we have what we call escalation. Okay, so if many subcomponent fails, rather than sending 100 alerts, okay, we can actually escalate this. Okay, so we can escalate this that a whole block failed or a whole division failed, and then this could have a much more serious response. Okay, good example, it could go to a site manager compared to a maintenance planner or a maintenance technician. Okay, this way everyone's in the loop and we can get the appropriate escalation. This one's great, probably my favorite. Okay, it's detecting anomalies and predicting failures. Okay, uh, talking to a lot of asset operators, okay, reliability engineers are kind of a hot commodity, okay, and it's rare that you have the luxury to have a complete team of it, okay. Maybe you're alone, maybe you're two if you're lucky, okay, and the expectations are really high, okay. They're expected to spot emerging patterns across thousands of assets, sometimes different assets, and ultimately, manually, it's pretty much not possible. Okay? It's not a sustained practice. This is where we can configure predictive and anomaly detection. Okay? A good example, or how I like to describe it, is TagMobi will learn what's normality for you. Okay? What assets are, how assets are behaving, and over a given period of time, it'll be able to understand what's abnormal. Okay? And at first, those notifications could just go through a report. And then as a human in the loop, we can actually code this or we can actually make this a real rule. Okay. So it's almost kind of giving you the solution. Okay. We'll have a deeper dive into the demonstration when it comes to anomaly detection. Okay? And then last but not least, okay, this one I think is just something that sets us apart. Okay, it's easy to govern multi-site operation. TagMobi has really been built with that in mind. Okay, we saw it with Voltwise. They scaled from one pilot to 11 sites, doubling in the next few years. Okay, so we provide reports for asset manager that essentially oversees multiple sites. Okay, this way it's easy to compare one site to another. Maybe one site has a different maintenance playbook, or if you just want to run some pilots improvement, makes everything easier. You get a one-stop shop for all your assets. All right, enough talking without any further ado. Let's get right into the demonstration. All right, so for our demonstration today, we'll just provide a bit of context. Okay, so we are logged in into TagMobi. Okay, I am a super user, so that's why you'll see a whole lot of menus and functions, but please keep in mind that we have, of course, full-on profile, so you could really tweak the application to what your different users should or should not see. Okay. A bit of context, this is a solar farm operator. Okay, so our data set or our asset structure here, you'll see three different solar farm, Alpha, Beta, and Charlie. These, of course, are fictitious sites, and I can explain them. Okay, so if some of you are familiar with functional location, that's exactly what this would be. Okay, and you can drill down into some subcomponents. So in our farm here, we have three arrays, one inverter station, a substation, monitoring system. You get the idea. Okay. If I drill down in my array, could have different cabling system mounting all the way to our trackers here. Okay, so this is what we'll be focusing on today. We'll get some live data out of our trackers, and then we'll be able to create a work order and then look at the cost. Okay? So the agenda for the demo is essentially mimicking what we've had on our slide. You remember the 4 steps. So ingesting. So we'll do that right away. We'll essentially import some data. And then step 2, decide. So we will create and we'll take a look at some monitoring rules that we have in place. Step 3, we'll be doing the work. So we'll be impersonating a technician, completing a work order, and then step 4, proving. Okay, so we'll go into our financial system. We'll be able to take a look at the labor time we spent, at the spare parts we've consumed, all of that in real time. Okay. Before I get any further, you've probably noticed that the pace picked up. Okay, and that's because We have a pretty loaded agenda for our demonstration, as you can tell. If you have any questions, anything catches your curiosity, okay, just use the chat, okay? And then it'll be a pleasure. We can schedule some time one-on-one, or maybe you have a question for the end of the webinar. So we'll be doing that. All right, let's go under our IoT module here, okay? And what we'll do first is we'll take a look at some configurations, okay? Don't want to spend too much time here, but I think it's good that we start with that. We have a nice graph here of our system architecture, okay? Essentially, you see TagMobi, it's our application here. You see our edge gateway that's connected to our trackers, our SCADA system, okay? We have middleware here, and ultimately everything goes into a time and series database, okay? We have a system status check, tells us it's healthy. We have 2 out of 2 of our active connections, so this looks great. And if we scroll down quickly here, we have some data retention policies, okay? Quite standard setup, but of course you can tweak this based on your requirements. But if we just take a quick look, okay, sensor reading, okay, so these in our case will be temperature, pressure, vibrations. We'll keep that for 30 days, okay? Equipment state, we'll keep that for a year, okay, 365 days. And alarms, we'll keep that for double this up, okay, for about 2 years, all right? Of course, device lifecycle, this one will stay forever or permanent. If you have any questions on data retention policies or where this is hosted or hosting provider, okay, we won't have time to cover that today, fortunately, but you can always schedule some time with me. All right, let's do step 1 now. Okay, so step 1, ingesting. So we have a few devices here already, but let's take a look at how easy it is to import or establish a connection. Okay. So if I click import, we can define our import method, okay? CSV and JSON, quite popular, okay? I'll do a simple CSV example first, okay? And I'll do this in dry run, okay? So that's a feature we've implemented. It's not only for demonstration, but a lot of time maybe you're just doing some tests. You don't want to mess up with some of the devices you already have set up, okay? So just turn this on, dry run mode. It won't actually create the devices, but it will run all the validation as if you would create them for real. I can choose a file here and I'll go under my downloads and I have a file. And there you go, already processed. I have 40 devices. So let's take a look at what it did. So these devices came out of my CSV import, okay? And what the system did is it mapped or reconciled with our asset ID, okay? So this coming from our CSV, or in your case, maybe your SCADA, maybe an open API of some sort, doesn't really matter, okay? If you're not sure, okay, please just interact in the chat. And then if you have some specific fields, if you're using specific SCADA, let us know, we'll work it out. And an asset ID comes from the asset structure that I've shown a few minutes ago. Okay? Of course, we could edit this if something's wrong, if the AI match was not exactly right or what you expected, you can simply edit. Let's say we're happy with this, we can click validate devices. We have 40 of them here, okay? And then this will batch register our device, okay? So here we had 40 in total, 39 are valid. Pretty happy with that. 1 skipped, and it skipped because I've already uploaded it, okay? No errors. So we have this validation completed here. Okay. All right, let's move on to step number 2. Okay, so if we remember our slide, step number 2 will be deciding, okay? Before we get there, we'll use Mobi Mentor. We'll here ask Mobi Mentor. We'll switch from personal assistant to IoT expert. Okay, sorry for that. I got confused. Okay, and here we'll just tell him in plain English. Okay, create. We'll do please. We'll stay polite. Okay, so please create an IoT monitoring fairly easy. Okay, I'm just prompting our IoT expert. Okay, now it'll take a few seconds, if not minutes. Okay, so what we'll do in the meantime, we'll let it run. We'll come back to it by the end of our demonstration. Okay, in a few minutes. We'll do the good old way. Okay, we'll just check it manually for now, but I promise we'll come back to our expert. Okay, so here we have our device number 2, okay, on our tracking actuator system, and you see the data is coming in live at the moment. The graphics will look a little funny for now, but as soon as we'll get about a minute of data, you'll see some curves that start making sense. Okay. In the meantime, just focus on our temperature here. Okay, so here, quite easy. I have 3 different thresholds. I have above 90, critical, not great. Above 59, okay, give out a warning. Above 20, assume an error. Okay, should never expect below 20. You see the data keeps coming up. Okay, what we'll do, we'll just take a deep dive into our monitoring threshold. Okay, so we'll open this, we'll edit it, we'll see what it looks like. Okay, first our tags. Okay, so we need to apply, of course, a scope to this threshold. This one's easy. It's asset specific, so I have an exact asset ID. But what you'll see most of the time, and that's probably exactly what you'll see with our agent, is that it'll apply it to an asset group, apply it to all of our trackers. Okay, so of course, if your trackers share the same threshold, the same condition, it's much more efficient to apply the scope to the group rather to each and every single assets. Okay. If we take a look at thresholds, these will be the 3 different thresholds that we saw on the graph, but here you'll see it. Okay, when my temperature averages, okay, for a minute above 59, get a warning. Same goes for critical and error. But automation is really, why we're all here today. Okay, so what happens when we get warning and critical? Action type, instant work order. And then with a given template, I have this template I've already created beforehand. Okay, and this will create a released work order for us. Okay? Escalation, we can quickly take a look at escalation, but we've talked a lot about alert fatigue. This is how you fight this. Okay, so depending on the condition, you could suppress alarms or you could escalate them. Let's say in 30 minutes, we've had 3 times this alert. Maybe we go to the next level. Okay, maybe we send an SMS to our asset manager and we have a different response and not overload our operators or technician. Speaking of notifications, of course, you have the Mobi integrated notification. These would be the 11s that you see here top left, but what I like a lot is Teams notification or Slack if that's what you're using, SMS. WhatsApp's coming soon, but super easy to configure. Microsoft Teams, turn this on, specify the webhook. Okay, so this would essentially specify what channel or what conversation I want this notification to go to. And once again, fighting alert fatigue, you can have a notification cooldown so that it doesn't spam you. Okay. It's quite straightforward now. Let's see if Mobi Mentor is still working through this one. All right, so we got it here. So tracker high temperature, so created a rule ID, gives us our rule key that we could go look at, a rule name, and then you see here warning, and then a critical above 55, 59. Okay, evaluation frequency every 1 minute, so pretty close to what we've looked at. Okay, and pre-configured some notification for us. Okay, alerts are pushed to Microsoft Teams via HTTP webhook, and then here kind enough. Okay, let me know if you want to adjust anything, so we could iterate as many times as we need on that until we get our step 2. Remember, deciding, figure out. All right, now let's get into step 3, the work. Okay, so we'll go under documents, we'll go under work orders, and surprise, we have an IoT alert, temperature above warning threshold. Okay, Here, what I'll do is I'll simply go report maintenance. Okay? And of course, this is all configurable depending on your requirements. You could add or remove some fields, make some fields required or not. Okay. But here, what I'll do is say that the inverter was fried and not what triggered warning. I replaced it. We'll complete this work order. We could create a follow-up work order if we wanted to change something. That's a nice feature we have. Okay, if you're interested in this, or if just work orders are, if you have some requirements, let's say you need to input some failure codes or maybe any tracking, let us know what your requirements are, and then we'll be able to take a look at that. But for now, we'll keep it easy. We'll say that this took 4 hours to replace. We'll add some usage. Here I'm picking an inverter. We have 77 in stock, and then we'll be consuming only one for this job. Attachment, of course, I'm demoing from the comfort of my office and desktop, but probably a lot of your users will be in the field, okay? And they will probably be using a handheld device. Okay? What's great with those devices, they often have a camera embedded, okay? And this way they can add a picture. What I'll do here is I'll just browse a file and then I have a picture of a fried inverter. Oh no, okay? But you could have just simply snapped a picture if you had a camera. So here, easy enough, we'll simply submit this work order. And you see now I have my maintenance report. So this is giving me a bit of insight, making sure everything's all right. I got my notes. I have my finished work order. Awesome. Okay. We'll return to our previous screen. And what we'll do here is we'll go into our financial system. So this is the beginning of the end, okay? Beginning of step 4, proving. So how does this look like from a financial perspective? Okay. Pay attention to my finished work order count. I'll refresh my dashboard here. So it went from 5 to 6, and then you'll guess that this will be our finished work order we just completed, finished work order 10. Okay. Now I can take a look at my statistics. There you go. I have my labor cost here, about $200. Okay, my item cost of 120. That's coming from my inverter, and my total cost. Okay, don't have to wait for the end of the month. We don't have an API that needs to sync. Everything is native inside our Microsoft ecosystem. Okay. If we take a look now at our item or posted usage. If you've been following along, you remember that we had 77 in stock, and then of course now 76. Okay, so real-time item inventory tracking, we have our negative adjustment a few seconds ago. So that's it for our demonstration. So once again, step 1, ingesting the data. Took a look at that. Step 2, deciding or using Mobimentor to help you decide. Step 3, completing a work order. And then step 4, proving. Okay. All right, let's go back to our presentation and let's take a look at a few more slides before we wrap this up. So if we zoom out and ask what changes at your operation when this loop closes, okay? To me, there's really 6 things that happens, okay? The first one, most obvious one, of course, would be faster response time, okay? That's because it would automatically route critical issues to the right team. And an immediate consequence to that is, of course, less downtime. These two really go hand in hand, okay? If you detect failures before they impact operation, you'll of course have less downtime. In the broader scheme of things, okay, this will have an improved overall asset performance. Okay, so identify production losses, improvement in equipment availability over time, just making you look better as an asset manager, as a maintenance department. Okay, another, I would say, indirect consequence to these, okay, would be just overall better maintenance planning. Okay, you would shift from chasing your tail, so to speak, reactive fixes, fireworks, okay, to more of a mature, planned work approach. Okay. Ultimately, you'll have fewer ignored alerts. So we've talked about reduced alert fatigues. We saw some of our control alert flawed functionality. So just essentially better discipline over time. Okay. And last but not least, okay, financial visibility into Microsoft Business Central. Okay, so tracking your cost over time, think labor, inventory. I'm kind of a broken record here, but that's really going to be what your leadership team will look at the end. The goal, faster operational response. So we've talked a lot about battery energy storage system, and in some of our use case, we're in the solar, but I wanted to maybe just give a big picture of some of the different assets, we could support with some telemetry profiles. Ultimately, anything could be an asset you manage with tag, but these are good fits. Okay. We won't go through each of these. If you recognize yourself here, if you're curious, take a deeper dive. Okay. But maybe some of the typical triggers we would see in wind, because we haven't really talked about wind power so far, would be vibration anomaly. It's probably the biggest show and tell. Oil temperature, pressure, pitch error, just position. So if you're operating maybe some wind farm or some wind-based assets, if you want to drop in the chat, okay? Or if you're operating assets that are not on the slide, I'll be curious to learn more about your business as well. Ultimately, okay, let's do a quick comparison. Okay, so why would you want to consider using Business Central and TagMobi? Okay, most of you are probably on the red box on the left here. Okay, so traditional IoT monitoring, you have dashboard without really any actions taking place. There's probably alert fatigue in your team. Okay, it's difficult to get real-time visibility and cost. Okay, and one of the questions I like to challenge some clients with is, okay, can you give me in not the last quarter, but last week, okay, even the day of, what has been your incurred cost of maintenance on a given asset? Okay. And I would say most of the time the response is, I don't know, is I'll need to take time to prepare this report. And how we change that, okay, is if you look at our box on the right, okay, is really having signals automatically triggers workflow, most likely work order creation, and tracking costs in real time. Okay, so this is the slide for your finance team. Okay, so if you need to share this to some of your controllers, some of your CFOs, let's say, this will be the timestamp and the slide they'll want to land to. Okay, so it's really about having a connected maintenance system and finance system. Okay, what I see a lot is a disconnected ERP. Okay, whatever it is, where they manage procurement and financials in there. Okay, and then we have an asset management system that's completely disconnected. Okay. What this means is that we need to reconcile often at the end of the month the costs to the assets. Okay. This means is that you're essentially operating on delayed data. Okay. And what's also interesting is the economics behind that of having subscription for those two systems, for both an asset and an ERP system, often becomes more expensive. Okay, so if you get kind of if you get both Microsoft and TagMobi at once, it can be 33% cheaper on average. We're talking for a site that's about 100 users. Okay. Another stats that I like here, top right of this slide, is one avoided unplanned failure can offset the cost of a multi-site, not one site, multi-site TagMobi deployment. Okay, so you're really asking yourself, okay, you know, are you anticipating any failures at one of your many sites? You probably have a business case to deploy TagMobi. Speaking of business case, okay, we are here for you. Okay. So in this slide, okay, it's a slide that I wish more operator had really seen before, okay? But we're essentially giving tips and tricks, okay, methodology on how to bring this case to your leadership team, okay? First, who should be in the scoping room? And some of the mistakes we see often, okay, is that we have operations, we have asset managers, but we're not looping in the two following stakeholders early enough. Okay, needs to loop in the information system or information technology team because often they will own all the security aspect to it, all the networking integration, maybe even the vendors for those sensors. Okay, so they need to be in the room. Okay, they need to have a seat at the table. And then as well, last but not least, finance and controller. That's often going to be a big part of the decision makers. There's an important stakeholder. They'll be the one that can unlock budget if that's not already done to make those changes happening. But optional. Some of you are not the asset owners, you are only the operator. So of course, we'll need those stakeholders at the table as well. Okay. If we take a look at what a realistic 12-month roadmap should look like, okay, month one, really set expectations that this is going to be discovery, okay? Go very narrow, do exactly what Voltwise did, okay? One asset class, very simplistic KPIs, okay, that we can all align to and that we all agree will deliver value. Okay? Month 2 to 3, this is where pilot sets up. Okay, so device mapping, we have Mobi Mentor AI to help you out. I reiterate myself, but rather than having to code some of those rules, all you need to do is in natural language explain what you're trying to achieve. Again, it can even suggest some rules for you. When the pilot is set up, okay, we want to expand it. Okay, so maybe move on to a secondary asset class that would still bring on some value. And then from 6 to 12 months, that's kind of the easy part. You have your recipe and then you scale it. Okay, so maybe go to another site, okay, build out dashboards so that leaders are informed of the improvements you're making. Now, really, what to expect, and I want to be transparent here. Okay, this is when the return on investment shows up. Okay, reality check for some of you, data cleanup is often bigger than expected. Okay, especially if you've been only using Excel spreadsheets or if your current maintenance system, has some limited functionality. There's probably going to be some data hygiene that you'll need to partake first. Okay, reality, okay, threshold take 2 to 3 tuning cycles. Okay, so you remember that's why we kind of start small. Okay, it took Voltwise, a bit of tuning to reach to that 95% was just the right, not too little, not too much. Okay, typically after 3 months, 90 days, we have our first downtime improvement metrics on our pilot. Okay, and then after 6 months, we can really get some financial insights out of the deployments we're making. Okay, so we're not talking 18 months until you see some return on investment. Okay, in 3 months, we see improvements to downtime. Double that, you can get some financial data to back it up.
Time for a quick recap before we open things up for Q&A from the audience. 5 key things from this session. 1, you have the IoT, you installed it, you've been investing in it. What you don't have is an automated path from alert to action. And you don't have an easy way to measure the financial impact of that action. Tag Mobi closes both gaps, the operational one and the financial one, through one closed loop embedded in Business Central. And the way to win is to start narrow, as Ben mentioned. One asset class, one KPI, one closed loop. Prove the value in 90 days, and then scale across your portfolio. 3 concrete steps if today resonates with you. 1, you can book a 30-minute discovery call with Ben. Hate to sell you out like that, Ben, but it's in my script. The QR code on the next slide will take you right to his calendar, and you can book that call with him. Step 2, you can try the interactive demo at verosoftdesign.com. Just click through the tag Mobi IoT experience yourself. No scheduling required, no QR codes to scan. Or 3, read the Amin Renewables case study on our blog. Same operator we talked about earlier, written up in a little more detail. Good one to share with your CFO if you want to start that internal conversation we've been alluding to lately. All right, time to open it up for some Q&A. We've seen some questions come in. Let's start with this one, Ben. We already have a SCADA system and inverter monitoring through our OEM portal. How does TagMobi work with what we have, and do we need to replace anything? Ben, your thoughts.
Yeah, that's a great question there, Paul, and that's one we hear a lot. Okay, so TagMobi doesn't replace your SCADA system. Okay, it integrates to it. Okay, so we'll fetch. Remember our four steps on the previous slide. Step one, ingesting the data. So we'll fetch that from your SCADA system. You don't have to invest into new sensors. Okay, you keep your existing monitoring stack, and then Tag provides essentially the workflow layers on top of it to go from single to wallet.
Another question here from the audience today. This one about pilot timelines. How long does a typical pilot take from kickoff to first closed loop work order?
Yeah, and that's something to be honest, a realistic answer would be 4 to 8 weeks, okay, to really get to a pilot from a single to a closed loop work order. This variance really comes from, how accessible the data is from your monitoring system and, how aligned your team is with the workflows, what should be the triggers, what should be the response. But best case, 4 weeks. I've seen some clients do it quicker than that, okay? And then at the worst, I would say 2 months.
Ben, I got another one here, and I wondered if this one was going to come up because when I first heard this, I was like, well, what if you don't have Business Central? That was the first thing that came to mind, and we did get a question about it. Can we keep our existing ERP if we're not on Business Central?
Yes, yes, of course, assuming your existing ERPs would allow for integration, which most of the cloud ERPs would do now. Okay, this would add some complexity to the project, but it's something we've done a lot. Just to name drop a few. Okay, Oracle, SAP, NetSuite. Okay, they would all work. Okay.
Another question from the audience. How does Mobi Mentor AI fit into this? Is it required? Is it optional? How does that work, Ben?
No, and it's a good question. It's optional, but all of our license plan includes some AI capabilities. So I'm really trying to educate client on it, push client into this digital change. Okay. First, to me, a good way to introduce it would really be those natural language rule creation. Okay, so describe what are your issues, what you're trying to achieve, and to me, it's not sophisticated. You don't need to configure anything. Okay, they're deployed from day one.
We got time for a couple more questions. This one gets into the weeds on battery storage operators a little bit. The question is for BESS operators specifically, how does TAG handle warranty documentation and condition history for any disputes with your OEM?
Yeah, this is one of the probably the strongest use case we see on battery energy storage system. Okay, so every work order, every condition event, every maintenance action gets recorded into work order history, which is linked to specific assets. Okay, so when the time comes when you need to go back to your OEM or OPC, okay, you have all of that data available to essentially make a claim. Okay, because warranty claim have lost grounds on documentation, and now they win. You have everything you need. And maybe going back to the previous question we had on AI, okay, you can also use an AI agent rather than go fetch and download all of those reports. Okay, could just say, hey, we have an issue with block one. Can you generate a report of all intervention we had since the asset birth?
I'm glad the AI agent hasn't come for me yet, Ben, because I've got one last question for you. And this one's about dollars and cents. We saved the nitty
Yep.
gritty for last. What does pricing look like per site, per asset, or per user, Ben?
Yeah, I knew this one would be coming, Paul, and I have to give my honest answer here. It's difficult for me to give pricing on a webinar. Okay, I think what's best is really scan the QR code. We'll get on a call. I need to get a sense of, what's the scope, how many sites do we have, what's your current SCADA system you have in place. But what's really key here is that the model is flexible. Okay, so whether you're one site or you have 100 sites, okay, I'm sure we can find some economical point here for you to switch to TagMobi and Business Central.
All right, thanks, Ben. That's about all the time we've got for today on this web event. We appreciate every single one of you for not only watching, but hopefully participating and even sticking around to the very end. If you asked a question and we didn't get to it, don't worry. Ben is on it Just drop it in the chat if you haven't already, and Ben will follow up with you directly. That QR code still on your screen will take you directly to Ben's calendar if you want to talk through a pilot scope of your own. A special thank you to Ben as well as to our friends at Verosoft for presenting this live web event. Just a reminder, we will archive this presentation. You can access it on demand at any time on factorthis.com. We'll even go as far as sending you a reminder email message if you registered for the event that has a direct link to where that presentation will live from now on. We'll also be sending out the slides and a couple of resources you saw here in the session. If you spot a survey link pop up in your webinar chat and you've got a moment to spare, we always appreciate your feedback. If not, no big deal. Thanks again for your time. We'll see you in a live web event just like this in the future on Factor This. Be good, everybody.
Thank you, Paul.